Hello and welcome to another video from Flash Jazz Cat, indeed the first video of 2025. Now I must apologise if I cough and splutter throughout this video. As I happened to mention, I think on the Patreon page just before Christmas, a couple of days before Christmas, I was struck down by what I assumed to be a cold at the time, but it seemed more like some sort of flu. It had me literally on me back for about 2 weeks. Nearly a month's gone by now, and I'm still struggling to throw the thing off completely. I'm absolutely exhausted most of the time, so I don't know what's going on there, and I've had a bit of a problem with my hand. Not the same problem I had the previous year, but a problem with a different finger, and we had a few other problems I mentioned in the Patreon post that I made, basically to explain the lack of activity over the Christmas period and the beginning of the new year. But anyway, we must forge ahead. What we're going to do in this video is have a look at the new version of SpartaDOS X that was released on the 23rd of December, the very same day I fell ill with the flu, but I did notice it anyway, and of course this has created justifiably quite a large amount of interest, and a couple of patrons were interested in some sort of a guide on updating things like the Ultimate 1MB and the SIDE3, because although the instructions that come with SpartaDOS X are routinely excellent, it's a remarkable product considering it's all free of charge. The new versions of SpartaDOS X are actually based on a disassembly done some years ago by the Polish DLT team of I think it was the FTE version. It was either the FTE, the ICD version of SpartaDOS X. That was the commercial product, and there was never publicly available source code, no support documentation, technical documentation as it were, no programming documentation. They liked it so much that they thought they could improve it, so they actually disassembled the whole thing and reverse engineered the relocatable file format, the executable formats, the symbolic linker, all that stuff. Absolutely remarkable. And this is the latest release version, SpartaDOS X 4.50. What I'll do is I'll download it, because I haven't downloaded it or applied it to any devices yet, so this is going to, I know how to do it, but the point is I'll be going through this in real time. So let's head over to the SpartaDOS X project page, download the packages that we need for this particular machine. I could have done this in an emulator, of course, but I thought it'd be nicer to do it on an actual machine and actual hardware. So that's what we're going to do. So let's head over to the SpartaDOS X project page and download what we need. So this is the Atari Age forum post that announced the release of version 4.50. Just something to mention there, that they used to release interim preview versions, and they're going to stop doing that now. You could release preview versions directly from this download link up here. So they've stopped that. I'm assuming they just didn't get any meaningful feedback from those preview releases. So for the purposes of what we want to do here, I'm going to download the toolkit, and I'm going to download, for the target machine, I'm going to download the SIDE3 image and the Ultimate 1MB image, and we'll have a look at what's on them. I don't quite know what this is here. There's something funny I noticed when Conrad was talking about the Ultimate 1MB and the Incognito builds, that he said they were identical. Well, they're not identical, because the Incognito version has the Colleen Sys driver, and that's what allows you to use the Incognito hard disk, the compact flash hard disk, in Colleen mode, which is the compatibility mode, and that's simply ignored when you've got the thing in XLXE mode. Now I'm a little bit perplexed as to why we've got these. Why is there in a Colleen mode? Well, we'll download them and we'll have a look anyway and see what's actually on them. Now we can also, which we'll use to browse these images, we'll download the SpartaDOS X Imager, which we can use to actually see what's on the ROM images before we even flash them to a device. Okay, so I didn't really need to open the images to see what this means. The Colleen mode in parentheses after this Incognito ROM here. It's completely redundant. It's the Incognito ROM and the Colleen mode driver for the hard disk. It's just ignored when you switch the device into XLXE mode. So I don't know why it's got Colleen mode there. It just seems to imply that the driver is present. Strictly speaking, you could use the Ultimate 1MB SpartaDOS X ROM on the Incognito. You could flash it to the Incognito and it wouldn't do any harm. And we've got Incognito there as well. I don't understand why they kind of mixed it up there, because that should just say Incognito. Incognito should be removed from that, because if you've got an Incognito, chances are you're going to want to avail yourself of that Atari 800 compatibility mode at some point or another. And if you have the Ultimate 1MB build of SpartaDOS X installed on the Incognito, you've got no hard disk. That's basically what that means. That's the only difference. So it's a change from the norm, the way they've decided to label things up this time. I don't know why they've changed it, unless Conrad just forgot there was an actual physical difference between the Incognito ROM and the Ultimate ROM. I think Trub actually flashed this up. So if we go back to December the 25th here, Conrad says, in fact, there's no separate build for Incognito, it's the same as Ultimate. That's not true because of what I've just said, because the Incognito ROM, the SpartaDOS X ROM, has or should have the Colleen Sys hard disk driver in the ROM, and specified in the config sys on the ROM, so that the driver gets loaded when the system powers up. The Colleen Sys driver knows if you're in XE mode, it simply doesn't install itself. So it can be permanently registered in the config sys on the car device without causing any problem whatsoever. So back in December last year they had Incognito as it was before, but then they've introduced Incognito here. It's more confusing now than it used to be. You should have just kept it Incognito Ultimate 1MB, because they are different. There is a slight difference between the Ultimate and Incognito builds. Specifically, the latter includes FJC's Colleen Sys driver. So that attempts to clear the thing up, but I don't think it really does. It's become a little. Just keep it simple. So anyway, we're not going to mix and match things like that. They can name things how they like. That makes no odds to me particularly. What will happen is that somebody will flash the Ultimate 1MB ROM to the Incognito because it says Incognito there, and then they'll switch into Colleen mode and wonder why they haven't got access to the hard disk, and I'll have to sort it out, but there you go. But anyway, we've got the ROMs now, so I'm going to put them onto some media. So there's a couple of ways we can actually go about getting the media over to the hardware here. We can either use the SIO2PC and RespeQt, which is the peripheral emulator, or we can put the ROMs on the SD card of the SIDE3 here, and we can use the SIDE3 to update both the Ultimate 1MB and the SIDE3 itself. So we'll do that. We'll try that method first, I think. Right, so I've downloaded the SpartaDOS X 4.5 images, the ones we're going to use anyway, and the imaging tool as well. So all you have to do, we'll do extract all here, and I'll just move that folder so you can see it, and I'll extract the imaging tool as well and move that so you can see it. If we open the imaging tool, which everything insists on opening on the primary monitor as opposed to the one I'm trying to use to record what I'm doing, we can open the imaging tool. That's fine, I trust it, and we'll move it over here. The imaging tool, as I mentioned before, it allows you to make changes to the ROMs. Let's open the one of the Incognito ROMs, and I'll show you what I was talking about before actually. So we'll open the small one. Right, so here we get a nice overview of what's in the file, and we can't arrange them by type. That would be nice. It'd be nice if we could arrange them by extension. Never mind. We should see here. So that's the Colleen Sys driver that I mentioned before that's only present on the Incognito ROM. And we can look at config sys, which should have a reference to the Colleen driver, which it does, so that's all present and correct. And of course you can actually edit this config sys here, which is very useful, and this is of course how we actually reference the SIDE drivers on the standalone ROMs that go on the SIDE2 and SIDE3 cartridges, because that's where the driver can only be loaded from the config sys that's on the ROM. You can't load the driver from a config sys on the hard disk because the hard disk can't be read until the driver is loaded. So there's a bit of a chicken and egg situation there. So that's why we do that anyway. So that looks absolutely fine. The Incognito ROM is completely in order. So yeah, we can make changes, you can add more things. Another thing, actually I forgot to show you. There we got the F disk, that's the partition editor. But everything else you can find it on the APT toolkit disk that's on my website. Well, case in point, in fact, if we open up the SIDE3 ROM, you can see, if we sort by name again, we should have the SIDE3 sys driver. There it is. So that's the driver that allows it to use the hard disk on the SIDE3 in standalone mode when you're running SpartaDOS X. There's the clock driver, and if we go into config sys here, we should see references to both of those drivers, which we do, SIDE3 clock and SIDE3. And don't forget, when you edit config sys, regardless of whether it's on the ROM or on your on disk, the .sys extension is assumed, so you don't have to put that. The device command, I believe, follows the path as well, so you can have drivers on disk in a folder, and the path will automatically be scanned before they load the driver. And the path will automatically be scanned before the driver is loaded. This is why you always put the car device first in your path, because it's so quick to search, and if it doesn't find the driver there, it'll look at the other elements in the path. You can add absolute device names and paths in config sys if you want. But as I say, you never need to put .sys at the end here, because that's assumed. So happy with that. Now if we actually open the folders up, the SIDE3 ROM, really it's mainly useful if you want to manually edit the ROM file on the SIDE3. I don't produce any flashing tool that allow you to flash this 448 kilobyte ROM to the SIDE3. The only flashing tool I provide for SIDE3 is the one that actually updates the loader itself. But the one you're going to use generally is the ATR file when you want to update the SIDE3 ROM. I could produce a standalone flasher actually for the SpartaDOS X ROM. I'd probably make an interesting video in itself if I wanted to do that. That would probably be a good idea actually. That would be well worth doing. I think we'll do that. Alright, so I've connected SIO2PC to the computer itself down here. That's just going to USB port on the PC. And if I start the peripheral emulator program I mentioned before, RespeQt, I think this is a fairly recent version. It doesn't handle scaling very well, display high DPI scaling. I've got the display scaled so you can actually see it, because we're recording in 4K here. But this program doesn't handle it very well at all. The non-client area is still the same size. I don't know what the hell is going on with it. It's written in Qt. I don't know. It's just it doesn't look very good. I don't usually run it scaled. No, not to this extent anyway. I've got a folder more or less permanently mounted here, which is the destination folder for the compiler on my system, which makes it very easy to test things when we want to test something on real hardware. But anyway, we can go in here. I think it supports drag and drop actually. And if we drag the SIDE3 ATR image over here, there we go. We've got the SIDE3 ATR image mounted on drive 1, and if we now go over to the computer, so if you're going to do this on a system that doesn't have Ultimate 1MB installed, the procedure is identical to the way I'm going to show you here. So I'm going to basically turn everything off, because what we want to do is boot the system from SpartaDOS X on the cartridge itself. So we're going to, I think everything is turned off already, so we're going to make sure SpartaDOS X is turned off here. we're going to disable the hard disk here. I'm going to leave the PBI BIOS enabled because it's got the high-speed SIO driver, which is going to speed things up a little bit. Oh, the clock's wrong here. We'll set that. I don't know why that is. Okay, so everything's off, so I'm just going to save that. And I'm going to reboot the system because I've just put the switch into the SDX position here in a down position. So what we should get when we power cycle here, we should boot straight into SpartaDOS X on the cartridge, the existing version of SpartaDOS X, and then the flasher should auto run, which it does. Alright, so we'll hit a key. I'm not going to use SpartaDOS X IO because we've got the high-speed SIO driver in this particular case in the ultimate 1MB, and that'll handle divisor 0, which is what I'm using, so I'm going to select no to that. Yeah, SDX 450 ROM. Okay, excellent. That all looks good, so we'll press yes. It's going to erase the ROM, and here we go. You can't hear anything. There we go. So it's pretty fast, it's got a lot of data to shift. If I write a standalone XEX for SpartaDOS, which as I say I might do as a kind of a companion to this video, that'll be even quicker, and you could run that directly from the SIDE3 loader, which that'd be pretty handy. But anyway, we'll let this finish, and then we'll verify that SpartaDOS X has actually been updated on the cartridge. And if that works out, I'll show you how to do the ultimate 1MB. Okay, so that's finished. So I'll just press enter. I don't want to restart the flasher. And what we should get, and I'm going to switch this TV is having trouble syncing to this VBXE signal, so I'm going to switch sources here. That's just a quirk of this TV with some machines. There we go. Right. So I'll power cycle the machine with that flasher unmounted because it keeps coming up all the time. And there we go. SpartaDOS 4.5 23 12 24. So that has updated. We can be sure that we have the most current version. So I think what we'll do, just for a bit of an experiment, I'm going to try and quickly code up a standalone XEX, which we could use to update SpartaDOS X with the SIDE3 cartridge without having to use a peripheral emulator, and that would work on standalone machines. So let's have a go at doing that. Alright, so I've fired up Eclipse here. It doesn't look particularly nice. I'm not too happy with this whole scaling situation, but there it is anyway. So let's have a look. We'll find the flashers, if I can find them. It should be in, where the hell are we? Flashers. Right, so this is the flashing tool for the loader. So what we're going to do, we're going to make a new one here. I'm going to save it under a different name. I'm going to save it as S3 SDX 450. Okay. And we'll quickly just change SDX SIDE3 SDX flash tool copyright 2025. Quickly save that. Right, so what we're going to do, we're going to need the ROM. So I'm going to grab the ROM here from the folder. So we want this one here. I'm going to paste it into here. Alright, so we've got the ROM there. So the way this works anyway, because the files are so huge, that it just splits the executable into manageable chunks, 8K chunks. And so it actually flashes the ROM while the executable load is in process. and it just repeats the whole thing as many times as it needs to get through all the banks. So as I say, it completely removes the need to have any kind of disk image at work here. So there's a few things we're going to need to get rid of, but we'll get the basics out of the way first. So this section here, I think we're going to have to sort of recode this. So this is the section that pulls chunks of the ROM file, which is obviously going to be a completely different file. So we'll change this to the name of the file we've just copied. So that's SDX 450 SIDE3 ROM. But rather than iteratively repeating all these sections where it just pulls 8K chunks out of the executable file, I think we're going to make it so that it's a little bit more flexible. Probably should have done this anyway, really. So we can get rid of all that. Right, so we're going to wrap this code section here, I think, in a repeat section. So I think we're going to need some temporary variables, if I can remember how to do this. So the chunk size is always going to be 8K. Now, if we do some quick sums, the ROM file here is 448 kilobytes in size, and we can quickly, if we grab the calculator, we can figure out how many 8K banks that is. So 448 divided by 8 is 56. So we've got 56 banks. So this little piece of code here is going to have to repeat 56 times. So what I think we'll do here is we'll set up a repeat block. Now we know we've got to flash 56 banks of data, so we'll have repeat 56, and we'll put end R here. So this piece of code here is going to repeat 56 times. Now all this does, this is an initialization address for show reading. So all that does there is prints a message to the screen showing that it's actually reading the data. And then we set the load address to the address of the buffer for the next bank of data, and then we set the initialization address to flash block, which is up here, and this just runs this code here, which actually flashes the data to the target bank. So this is going to run 56 times. But of course we don't want the base offset to be the same every time, so we'll make ourselves a little temporary variable here which you can redefine. So this is like a normal equate, it's fixed, you can't redefine it or assign a new value to it, but with a temporary variable you can. And we will call that one offset, and we'll set it to 0. And it's gonna cover quite a lot of territory, so we'll have that as a 24-bit value. And we'll change this here to offset. So that's going to be our base address. And at the end of every iteration, we want to bump that offset by hex 2000. So what this will do is it'll actually generate 56 sections of code, 56 repetitions, but for each repetition that start address will change every time. And the code that actually flashes the data, that takes care of a flashbang. But what we do need to do is find out what the start bank actually is for SpartaDOS X, and I can't remember that offhand, so I'm going to have a look. And I'm assuming it's going to be in Avery's hardware reference manual, fingers crossed, because I cannot remember where it is. There we go. Right, SIDE3. So let's have a look. Right, so that's our bank number right there, 3CO, if we trust this information. Right, there we go. That's where the base bank actually gets set. So we'll change that. We'll make ourselves a nice variable here. SDX bank, SDX base bank, we'll call that. And we'll make ourselves a, don't forget to put that in front. And we'll set an equate here, and we'll call it SDX base bank. and we'll set that to 3CO. Alright, that should work. Now of course the base bank has now become 16-bit. Oh god. So we're going to have to change that as well. Right, so that's going to have to be in W. And I've made myself a new version of the JEDEC Flash library here because I'm going to make some changes to it and I don't want to mess it up. I don't want to mess the original one up. So FL bank here is going to have to become 16-bit. So that's going to become a word value now. Right, after a bit of a break in recording, because I hit some problems while I was modifying this flashing tool, as you might expect, I made a copy actually of the JEDEC Flash library, which is based on something that Candle wrote. Candle's more of an 86 person, so I have to modify the code to suit my requirements, but the basic concept was absolutely spot on. The first thing I did, because with the loader flasher, which uses this library, this same library here, it only uses the lower banks of the flash ROM, so there was no need to manage the 2 extra address bits, or the bank number bits rather, because we never strayed into those higher bits. But of course, in the case of SpartaDOS X, the start bank is 3CO. That was actually absolutely correct. So of course I had to go through here, and the variable in question is FL bank. As I say, a lot of these names are throwbacks to the original Candle code. But Flashbank is basically the 8K bank which we are dealing with at the time. And of course that was originally an 8-bit value, but of course we needed it to be 16-bit now, well 10-bit strictly speaking. So I had to topically go through the code here and just make some changes. There's a bit of bit shifting going on here, which I could probably make it a lot better because it was pretty much trial and error getting this to work. So there's our 2-bit MSB of the bank number there, which I've masked out any higher bits, and then I move those bits into bits 4 and 5, and then OR in 4, which actually turns on that particular bank A, because I've chosen to access the flash ROM at the right cartridge address, the right cartridge window at hex 8000. But I was so rusty on these bit functions here in the registers. It was a lot of trial and error, so I used Altera until I managed to get that right, and then I still had to massage things a little bit more because I had a lot of problems with the 64K sector erase code here, and eventually I tracked the problem down. What was absolutely a total boon here, which I eventually cottoned onto, is that Altera has a logging channel for flash operations, flash programming and flash erase, and I immediately figured out what my problem was. I needed to set the upper bank bits 8 and 9 before doing the first 64K sector erase operation. The first one was going to the wrong location, erasing the wrong sectors, which of course upsets the programming subsequently. But once I got that working, it worked fine. So I've tested this in the emulator, I've tested it on real hardware off camera as well, and I think this is really useful because as I mentioned, this means you can update the standalone side cartridge. You can already update the standalone side cartridge loader with the XEX, the self-contained flasher that I've published, I've been publishing for quite some years now, but we didn't have one for SpartaDOS X. You had to, basically we're completely reliant on the disk image that DLT publish. Well, not anymore. As I mentioned earlier on in the video, we've got this section here which repeats 56 times and simply bumps the offset when it's extracting 8K chunks from the executable. I mean, if you're wondering what the actual output file looks like here, I'll show you in the hex editor, in fact. This might help you to understand the file structure. The actual tool itself, you can see all the text here. It loads at hex 2000, which is the safe load address above DOS, and there's not really that much to it, a few hundred bytes, text messages and whatnot. Now this is the interesting part, because these are initialization addresses. So you get 8K of, there's basically 8K of SpartaDOS X data here, so that will take us up to 6,000. There we go. So there's 8K of actual ROM data. So, and then we've got an initialization address here which jumps to the code, which flashes whatever is at hex 4000 to the current bank. Then we've got one here which will be that'll execute the reading bank whatever on the screen, and then we've got another 8K of data. So these initialization sections displaying messages on the screen, flashing the data to the ROM itself, the flash ROM, and then setting up the next bank, and it does that. We've got 56 blocks like that. So that's how it works. So as the XEX file is actually being loaded in, it's repeatedly flashing the data to the flash ROM. And using this technique, there's absolutely no limit to the amount of information, the amount of data we can actually get through. Obviously, the bigger the data, the slower it's going to be, but this is particularly quick, of course, because this can be run directly from the loader straight off the SD card. Now, I didn't the approach I used with the UFLASH was totally different to this. The main reason being that at the time that pretty much had to be run from SpartaDOS X. Well, you could run it from other disk operating systems, but it was used with SpartaDOS X straight from the SpartaDOS X command prompt. Some of the time when you're going to be updating SpartaDOS X itself using UFLASH, so the whole ROM based part of the file system, since SpartaDOS X is ROM based, becomes invalid as soon as you erase the banks to actually reprogram them. There was a bit of a chicken and egg situation there. So what we had to do was have all the data loaded into RAM first, then erase what parts of the flash chip needed to be erased, and then program the data to it. So we didn't have to actually have recourse to a working file system driver while we were loading the data from disk. And that works, but it does impose pretty severe restrictions on the amount of data that you can actually get through, because it all has to fit into, well, in that case, a megabyte of RAM. Now, the flash chip on the Ultimate 1MB, for example, is only 512K, so that's not really a big deal, and it's got a megabyte of RAM on it anyway. But now, with SIDE3 and some of the other work-in-progress upgrades that are basically based on the same hardware, we've got an 8 megabyte or 2 megabyte or an 8 megabyte ROM chip. So it's a completely different kettle of fish. We can't really load huge amounts of data into RAM. As it happens, this particular SpartaDOS X image, what is it, 450K, we could load it into RAM. But I've kind of cooled to that method now. I think, especially since I made the fat DOS for the SIDE3 loader, which basically means you can run UFLASH or any flashing tool straight from the loader without recourse to having SpartaDOS X present at all. So you could update SpartaDOS X without any consequence, because it's not actually active at the time. It's not providing the file system driver. So that's made me move away from it. The only other bit of contention you would run into is if you're actually updating an active operating system ROM that's provided by the flash ROM. Easy way around that, just run a RAM-based operating system for the duration of the flash. That solves that problem. So I think going forward, I'll move towards this method. This doesn't mean that we're confined to standalone pre-packaged flashing tools like this. Not at all, just the opposite. In fact, the code for this tool can pretty easily be turned into a generic flash tool that can be run from, say, the SIDE3 loader, and then just run a directory of whatever's on the FAT partition of the SD card. Pick the file you want, tell it where in the ROM you want it to be programmed, and off you go. And DOS isn't going to be upset by that, because the fat DOS resides wholly in RAM. And like I say, if you happen to be replacing the active operating system ROM, we can just run the operating system ROM in RAM, in shadow RAM, as a matter of course, which is no problem. So that's going to be a much simpler flashing tool. It's not going to need all the GUI stuff that UFLASH has, and there's an enormous amount of complexity with that tool. This would be much, much simpler, a lot more flexible, I think. It wouldn't have the fancy user interface, it wouldn't need it. So I think that's the way we'll go, and what this will enable us to do, if there's any point to it, of course, if it's actually going anywhere, but what it'll enable us to do is to have a generic flashing tool for all the devices that have these enormous flash ROMs like SIDE3, external Ultimate 1MB, Incognito 3, Incognito Lite. As I say, I've got no idea whether these projects are really going to reach fruition, but it just so happens that I got interested enough to write this thing, and along the way that provides us with an easy way to actually get content onto those ROMs. Now, the other thing I was thinking here, currently this just displays a rolling list of the bank number that's actually being read and programmed. So there'll be some message somewhere higher up here. And it's not really very informative to the user, because it would be nice if it had a sort of percentage complete kind of thing. That's a lot easier to understand. It's a lot more informative to the user. Who the hell cares what banks the data is going into in a pre-packaged flash tool like this? All the user wants to know is how quick's it happening, how much longer have we got to wait. So what I was thinking I would do is make a version of this which displays percent complete instead of just displaying the bank numbers, just to make things a little bit more polished before I release it. So let's see if we can go ahead and do that. Now I've got the Wishbone flashing tool here. This is the one that updates the actual JED file on the SIDE3, and I've just had a scan through it, and this is the code. Believe it or not, it's quite economical. This is the code that does all the percentage calculations for the actual counter on that tool. I don't know if I'm going to have to expand it a little bit or not. Probably will. But I thought it might be interesting to go through that and show you how that works. It's all done with integers. So let's have a look and see if we can adapt that and use it in the self-contained flashing tool I've just produced. So as I suggested earlier on, I've gone ahead and I have changed this so that it displays a percent counter using that code I just copied across from the Wishbone flasher that updates the JED on the SIDE3. I just made a couple of little changes. I changed the name of a couple of variables here. But the idea of this is basically we want to work out a value for our percent counter. Obviously we want to count up from 0 to 100, and we want to work out a value that we can add to the counter every time we process a bank and advance the percent counter appropriately. But this isn't going to work out if we use integer variables, of course, because 56, which is the number of banks that we want to flash, does not divide evenly into 100. So the approach I generally take here, and this is a very, very simplified implementation. I've used this approach for all kinds of things all over the place, scroll bars and things like that. It's very, very useful for things like that, where you don't want the overhead of having to use floating point variables, but you do need some sort of fixed point capability. So my approach to this, I don't know if it's the typical approach, but my approach to this has been to use the MSB of a 16-bit counter. So what I do here is I zero everything out first, and I've got a 16-bit counter here. So I've loaded up pointer 1 with 100 shifted left 8 places, so it's 100 multiplied by 256. And then I divide that using this very, very simple subtract algorithm here. I divide that by the number of data units that we've actually got, which is 56 in this case. And that gives us a fairly large 16-bit number. And that's what we're going to use. We're going to add that to percentage counter every time we process a bank. But when we actually display the counter, the value we're going to use is the MSB, because the MSB, because of this, is going to tick over in just exactly the way we want it to, thanks to 16-bit addition. So there's the code that displays the actual counter. As you can see, we're referencing the MSB of that counter, and there's still a bit of a rounding error, of course, there always is with these things. So at the very end of the process, I've got display 100% here, which just sets the MSB to 100 and displays the counter. I think with the accuracy of the thing, I think at the end it's sitting at about 98%. So it looks okay if you just bump it to 100 at the end and then display the counter again. So I've tested this. it's fine. As I say, I think it's a little bit more informative to the user. It's less verbose than listing all the banks. I don't think the user cares what banks are being flashed. It's completely subjective. But anyway, I've tested this in Altera. That's the first place I tested it. And I've also I did try, because I was curious as to whether the flashing tool that's on the ATR disk image distributed by DLT. I think I knew the answer to this beforehand. I didn't think it would work, because I think the flasher it goes directly through the SIO and it's got like a built-in SDFS driver, I think, because it doesn't want to be relying on the ROM file system driver, because that's going to be invalidated as you flash the ROM. So it's got a built-in SDFS file system driver, number one, and obviously we don't use SDFS in the loader, we use FAT. And secondly, of course, it calls the OS SIO vector directly, and the little DOS, the FAT DOS that the SIDE3 loader installs when you run an executable, it's not patched into the OS SIO vector. You need, if you're going to do direct sector access bypassing the CIO driver, the D driver, you need to call the soft vector. But anyway, I'll show you what happens. It runs, and then I press enter, and needless to say, we get a timeout here, because presumably what it's trying to do is trying to read the boot sector of the host file system volume, and it's immediately getting an error because the SIO is timing out, because the SIO, the operating system in this particular environment, doesn't understand how to read the hard disk, so that doesn't work, and that's entirely expected. But what we can do now, I've got a test version of this flashing tool. I think I called it SDX XEX. There it is. Right, so if we run this, identifies the chip, press yes, and here we can go. So each time that says, so it's flashing, it went 1, 3, 5, 7, 8. So each time that counter increments, it's adding that 16-bit value to the counter, and that looks okay to me. So we'll speed it on a bit, and there we go, it's finished. Press a key to reboot, and if we cold start the emulated machine, we should boot into the new version of SpartaDOS X on the SIDE3 cartridge. There we go. So it works in emulation. Alright, so let's give this a try on real hardware. I've put the executable on the compact flash card. SDX, there we are. Right, run that. Update and see how long this takes. The erase phase takes a little bit longer on real hardware, I notice. Well, let's see how it goes. So it seems to be chewing through that reasonably quickly. You can see the little light going there as it's reading in these 8K chunks of data. And it's speeded up here because I'm assuming because there's a lot of empty space, and the flash algorithm actually skips zeros. And there we are, we're done. So hopefully we will boot, well, I have to power cycle the machine, and we should boot into the new version of SpartaDOS X. Which we do, so that's good. So there you go. So that I'll publish that probably in time for the video to come out of Patreon pre-release. So that by the time this is generally available, I'll have that flashing tool on the website. Maybe a couple of patrons might want to give it a spin beforehand anyway, so we can iron out any potential issues, but that does seem to work. It certainly works when it's run from the loader. There's lots of additional considerations concerning safety if you're going to run it from, say, the SpartaDOS X prompt, for example. I'll have to try that as well, because then you get into all sorts of ROM management situations. When you run an executable from the SIDE3 loader, you're guaranteed that there's no extraneous ROMs in the way or anything like that. So anyway, so yeah, that works. Out of interest, just to be sure, I'm going to the hard disk enabled. I'm going to try it with SpartaDOS X enabled on the Ultimate 1MB. So now we'll boot into the older SpartaDOS X version on the Ultimate 1MB, and I'll update that as well. I'll show you how to do that in various ways, and then I should still be able to jump into the loader and run that same tool without any conflicts. And I misspoke earlier on, when it speeds up here, it's not because there are zeros in the file, it's because there's hex FF in the file. Because when you erase the EEPROM, it sets all the bits to 1. And programming in the EEPROM is a process of selectively setting bits to 0. So what we've got in the file, when it speeds up there, is just a bunch of FFs. And it's skipping them because it knows it's just erased the flash ROM sector, and that's guaranteed to have FFs in. So it knows that the contents of memory are already FF, and if the same location in the ROM file is FF, there's no need to program it. So that's why it gets through that. It gets through those higher banks really quickly. That all appeared to work perfectly well. So let's move on to updating the Ultimate 1MB itself. Since we're messing around with the SIDE3 loader, I'll firstly show you how to do it using UFLASH and the SIDE3 cartridge. So what I'll do here is I'll just grab the Ultimate ROMs. In fact, why don't I just make a folder? Right, SDX 4.50. That's a better idea. Right, so put all that stuff in there, and I want a copy of UFLASH as well. I think that's already on the... I think it's already there, but we'll put it in the same folder. Yeah, we'll put that here, the folder we just made. Paste that there. Right, I think that's everything we need. So we'll take that card over to the PC. Right, so let's start the SIDE3 loader. Navigate to that folder that we just created. And we'll run UFLASH. And it's identified the hardware. If it doesn't identify the hardware for any reason, stop there, send me an email or post on the Atari forum or something, because something's gone wrong. So in this case we just want to update the SpartaDOS X slot, so let's go into there. Now I happen to know, or it's worth checking, if you're not sure, press the escape key, and if we go in here, set SDX size, the highlighted item here tells you what ROM size you need. You can change that, but I mean it's kind of outside the scope of what we're talking about here. So I want the 192K ROM version. So of course we've got the short file names here, that's unfortunate. I should probably rename them before we proceed, because I can't really tell what they are. So let's change the names of these files. Well, we know the version number, so let's just get rid of that. And get rid of that. That'll do. Oh dear. Must have moved the Write Protect tab. And indeed it is. Yes. Write Protect tab was down there. Right, let's try that again. So the important thing is that we can tell what's what here. So we'll just change it to that. And we'll do the same with the other ones, just to make them short enough so that we can actually see what we're doing in DOS environments where the names are limited to 8 characters. Where's the 256? Where's the 256? Right, well there isn't a 256K ROM for the Ultimate. It's missing for some reason in the distro. Don't know why. But we don't need it anyway, so fair enough. Right, so back here again, so let's select SpartaDOS X. Let's go, now we can see what we're doing. So we want SDX UL192, press enter, and off we go. And it's reading the file into RAM rather quickly. And there we go, and we'll let that flash, and then we will check it when it's done. Okay, what we might as well do, we'll just do a power cycle because I've got SpartaDOS X turned on in the ultimate setting. So what we should now do when we turn it on is boot straight into it. So let's see. And we do. So there you are, SpartaDOS X is updated. Now another way of doing this, which I might as well show you if you haven't got a SIDE3 cartridge or anything along those lines, is we can use the SIO2PC. So we'll go back over to the PC, we'll do the same thing again. So what I'm going to do here is just mount this file. One thing I'm a little bit concerned about, I don't understand this. So they've got the 256K version of the SpartaDOS X ROM is in the disk image but not anywhere else, so we don't want that one. We want the 192K one. So you're going to hit problems more than likely if you've got the GUI demo on your Ultimate 1MB and its presence dictates the use of the 192K SDX ROM. You're going to have problems straight away. This is going to damage things. This is going to overwrite half of that ROM. I'm going to have to change this. Most people, unless they've changed the geometry of the flash ROM on the Ultimate 1MB, it's not advisable to use the ATR tool. I mean, there's not really an easy way around that. You could have what we need here. Well, I'll produce it for you. If we go to Altera, we can go into the Disk Explorer, open the image. So that's 256K. So we can get rid of that, and we'll drag into it that one, and we'll just change the name to that, and this should work, hopefully. So now if we go into RespeQt, mount that image again, and then if we go back over to the PC, now that we've corrected that, now we know we've got the correct size SpartaDOS X ROM on the disk image. What we should be able to do right, let's come up, hit the key, 192K, yep. So when I did a cold N there, as I said before, the flashing tool distributed by DLT actually has a SpartaDOS file system driver built into it, so it doesn't need to have SpartaDOS X actually active. And the reason for that, as I said before, is because the ROM is going to become completely invalidated. DOS is therefore going to become invalidated partway through the flash process, so it can't be used. So that's why I did cold N anyway, to turn off SpartaDOS X. It's not absolutely necessary, because of course even if you run the flashing tool from the SpartaDOS X prompt, as soon as it starts to run, it takes complete control of the file system and it's not going to call DOS at all. But there we go, so it's done. It didn't take that long. So we're rebooting into SpartaDOS X now. There we go. So I can get rid of that flasher now. I'll unmount it. What we should see as well is if we change this here, and what I want to verify is that the graphical OS didn't get completely destroyed. And it didn't. So if we'd used that 256K SpartaDOS X image that was distributed on the disk image, this would no longer work because half of it would have been completely destroyed by the flash process. So watch out for that. That's probably an advantage to using UFLASH because it's aware of the way the firmware is set up, so it won't let you use the wrong size SpartaDOS X ROM. Of course, you can also use UFLASH over the SIO using SIO2PC. So if we give that a try, so over on drive 2, I've got a virtual folder which should have UFLASH on it. Yep. So we'll run UFLASH. And again, we're going to go into SpartaDOS X, but we're going to change drives now. So I'm going to go to the drive that actually has the distribution ATR on it. There's the ROM. We know it's the 192K ROM because I put it there. So this will be a lot slower, of course, because it's working over the SIO, but it's going to do exactly the same thing that we did when we ran this tool directly from the SIDE3 loader. So they are a selection, the most common ways you could go about updating this hardware with and without a device like SIDE3. So there's bound to be questions in the comments, which is more than welcome. I'm bound to have forgotten something here. As I say, it was primarily Ultimate 1MB and SIDE3 guides that were requested, so hopefully you can get something out of it. So I hope you found it useful, or at least interesting, and maybe the insight into the little bit of coding that we did there was also of interest. Of course, this was the first video of the year. It's a bit disjointed. I've had constant setbacks with illness and all sorts of stuff that's going on. I've got tradesmen coming in and out of the house all the time because I'm trying to get estimates for the various repairs to the property that that the insurer is supposedly going to cover. So I've got a lot of phone calls, a lot of stuff going on. One thing I haven't got a lot of at the moment on is regular work. I've still got the machine that I featured in the last video to actually settle up on and ship back to the owner, but beyond that things are a little bit up in the air. So I want to thank you for watching. Thanks in advance for your comments and your likes and that sort of stuff, and of course special thanks to my patrons who are very patient when it comes to waiting for content, and of course you'll have seen their names at the beginning of the video. So yeah, thank you very much again for your support. It is genuinely appreciated. With that, I'll bring this one to an end, and I hope to see you in the next video, but in the meantime, bye bye for now.